Hello, friends. We are happy to have the opportunity to speak to you about our project, Constructing a Mathematical Foundation of Understanding, an online course for teachers, a case study on the order of operations taught conceptually. I'd like to start by introducing you to my colleague, Dr. Lori Howard. She is a professor of special education in the College of Education at Marshall University. She is a researcher and developer of co-teaching strategies, and she focuses, among many other things, on improving mathematical understanding for special education teachers as well as elementary teachers.
I'm happy to introduce Dr. Bonita Lawrence, Professor Emerita, Department of Mathematics and Physics at Marshall University. She's a research mathematician in the field of dynamic equations with a strong focus on teaching mathematics conceptually, including offering visual interpretations of mathematical theory. She's a great collaborator because she's retired.
Well, projects begin with commonalities, and we discovered that we both enjoyed and encouraged collaborative teaching and were strong proponents of that. We both were also interested in developing our students' understanding of how mathematical concepts are linked together.
Both of us understand the benefits of requiring students to write about their thinking process as they solve mathematical problems. We both believe in metacognitive reflection of the process of learning mathematics.
We discovered that we each a priori had a technique for discovering student questions about some mathematical concepts and how they were applied to solve problems.
From the education professor's perspective, I use a written exercise known as reflection assignments on lessons and instructional strategies.
And I developed something I call a conceptual learning exercise, which starts with a particular problem setting, and it requires the student to develop a process for solving a problem, a general process for solving a problem like that, the one that was offered. And then I asked them to apply their process to that problem that was offered and solve the problem. And with that commingling of ideas, our collaborative assignment was born. We discussed the influence of language on learning, and we wanted to weave this into the fabric of our ideas. We know from Vygotsky that language structures thought. So when you begin to teach students a certain topic, teachers always, you start with vocabulary, you use it, you define it, and that got us discussing conceptual learning, because the students need to link the conceptual idea with the vocabulary. Now, those conceptual ideas gathered together led us to some discussion about the axiomatic structure of mathematics, and that certainly involves using the symbols of mathematics. And so this finely woven fabric, it was developing. We know language fosters communication, and communication fosters learning. We all know the power of language. So the exercises that were developed, we asked the students to reflect on their process for solving particular problems. And we noted that this helped them organize their thoughts, ask questions to enhance their understanding, and this helped them create their own personal process for solving a particular problem. It asked them to gather all of the information that they needed ahead of time to solve a particular problem.
These exercises help create the linkages between the mathematical symbols and language. So it helps to close the feedback loop. This information often offers valuable insight for those who are guiding student learning. That's an understatement for teachers. The course that we are talking about is a graduate course in special education mathematics strategies. It's taught online in a 15-week semester. Purpose is for the teaching of math strategies for students with disabilities. We tested our ideas in the course using the mathematical topics, operations with fractions, and the order of operations.
We all know that 3 points determine a plane, and I'd like to show you this beautiful table of Lori's, this 3-leg table that sits on the plane of that beautiful floor. We also know that communicating on the same plane creates amazing ideas and learning. So I'd like you to consider this 3-leg table. What do the 3 legs represent? We need a topic to investigate. We need the collaboration of educators. And from that collaboration, the development of instructional strategies.
The student assignment that we created together has several important things. The students who are teachers or pre-service teachers must create a lesson outline for order of operations. The assignment has 4 important components. The first one is the objective for the lesson. Secondly, they need to define their instructional strategies, guided practice, peer learning, scaffolding. Number 3, mathematical expression. We will give them the mathematical expression. And finally, the 4th component, which we think is really important, is the self-reflection of what they learned, both mathematically and instructionally. Now we're going to show a video from Dr. Lawrence, which we use as scaffolding for this assignment.
Hello, friends. I'd like to talk to you for a few minutes about a video we made for Dr. Howard's graduate course in special education, and this is her Math Strategies course. The topic of discussion was the order of operations. And I started by reminding the teachers that our mathematical structure is axiomatic and reminded them of what that actually means, that we use a collection of basic statements. Often these are definitions, and we use them just for solving problems. We decided to equate these basic statements to a set of rules required to play a particular game. And I noted that the rules are necessary because you need to determine how each player interacts with the other players. And if you change the rules, then you have a game, but you have a different game. So what we need in mathematics is a common way to communicate and compare results. All right, so I started our investigations with creating a mathematical expression that we'll use. And I noted that I believe that each person has this mental mathematics toolbox that has gathered in it all of the things they learned in their mathematical education so far. And Dr. Howard will ask this group of students to create a mathematics journal, and then call a section of it their toolbox, their mathematics toolbox. I reminded the teachers that both they and their students have an understanding of addition and subtraction and multiplication and also division, and that they have also been taught that You can define subtraction in terms of addition, and you can define division in terms of multiplication. I then stated for them formally in these text boxes how that definition is formally stated for both subtraction and division. And then we came to the most important point that I was trying to make, which was that subtraction is a special form of addition and division is a special form of multiplication. And these will be the foundational ideas in our study for this video. So what we need to decide is if we need a particular order for applying the operators and utilizing parentheses. We'll start with an understanding that we will always, in our mathematical expression, we'll move from left to right, same way we read English and written English and also many other languages, and that the parentheses will serve as a signal, and it says calculate this part first, all right? So our structure for our game, calculating the unique value, will be, we're going to agree to move from left to right and apply the operators inside the parentheses first. Also moving from left to right inside the parentheses. Always moving from left to right. My favorite question is for all these things has always been why? And do we need an agreed upon set of rules for the order for these things, these applying these operators and using parentheses? And then I just said to the teachers, okay, let's investigate this. Let's see. We want to know, do we? And we want to know why or why not. That will be our first question. So I formalized the question, and then we started the investigation. And so I said, okay, suppose you way back in time, you get to decide how this ordering will go. Let's do a couple of trials in our investigation. And our first trial will be, trial number 1 will be, first we apply multiplication and division, and then we apply addition and subtraction. That's one trial. And our second trial will be just swap those. That backwards, didn't I? Our second trial will be number 2 will be just swap them. And so we'll first do addition and subtraction, and then multiplication and division. All right. So we went back to that expression I created, and we just started with trial number 1. This is trial number 1, multiplication and division. But we did agree that we first would do parentheses, so we add 1 and 2, and we get 3. We write the rest of the stuff, move back to the left, move across until we hit multiplication or division, and we get 2 times 6 is 12. We write the rest of it. Then we multiply, next line, we multiply 12 times 3, get 36. And then we divide 36 by 4 and get 9. And finally, we subtract after we've done all of the multiplication and division operators. So we end up with, in that case, with 9. Now for trial number 2, we said we're going to swap that out. We'll swap that out for trial number 2. And so we rewrite the expression. We've agreed that we're going to do parentheses first. So in whatever order comes in the parentheses, we do that first. So we add 1 and 2 and get 3. But this time, since addition and subtraction comes before multiplication and division, we're going to subtract that, get 16. Then we're left with just a string of multiplication or division. So we multiply 16 by 6 and get 96. Then we multiply 96 by 3 and get 288, and then finally we divide by 4 and get 72. So the question was, first of all, do we need an order? Well, yes, we do. Because if we don't, it's possible that we'll get two different values. Thank you. Well, the uninvited guest is PEMDAS. We haven't mentioned it at all so far. And PEMDAS is a mnemonic that was developed and is used to help students learn how to use the order of operations. And the PEMDAS represents parentheses, exponents, multiplication and division, but they should be on the same level, and addition and subtraction also on the same level. Now, there's some issues concerning just introducing that as, if that's the only thing you do. And Lori will talk about some of these issues that we've discovered, both of us have discovered.
Many teachers and students know the mnemonic, which helps to focus on the items for the expression. However, with many students and some teachers can easily state the order for the operators, they often cannot solve the equations. We believe that we need to teach conceptually the rules of the game of math before introducing the mnemonic. Not all students learn mnemonics easily. So many students lack the conceptual understanding of why the math works, but they can tell you all the words that go with PEMDAS. We want teachers to teach conceptually before introducing mnemonics.
We'd like to thank you for your time and your attention. I bring greetings from Huntington, West Virginia. This is a picture of the Frank Gunner Gatsky Bridge over the Ohio River near Huntington, West Virginia. We have some references for you on the next slide. And if you'd like to, go ahead, Lori.
I was going to say, and if you want more information, please feel free to email us.
Thank you.
Thank you.